So let's have an example under area moment method for beam deflection. So for example, we have this beam, let's say EI to be constant, or the product of the modulus of elasticity, and the moment of inertia of the section will be constant. So required the rotation at A, the rotation at B, or slope at A, slope at B, the maximum deflection of the beam. So first thing to do is, of course, I need to determine the support reaction. So this is 4 kilonewtons. Ito naman is 8 kilonewtons. Okay, then after computing the support reactions, you are to pick a fixed point wherein you are to draw the moment diagram. So this moment diagram is not the same as the usual moment diagram from our previous discussions. So for example, I will choose a fixed point. Okay, so for example, I'll be choosing a fixed point, point B. Then we are to draw the moment diagram. So what is the moment caused by 8 kilonewtons with respect to point B? That is the same as 8 kilonewtons times 3 meters. That will be equal to 24 kilonewton meter. Okay? So 8 kilonewtons times 3, that is 24 kilonewton meter. So area above will be positive, and will be having area below will be a negative area moment. So this is 12. With respect to point B, that is 12 times 2. This is negative area moment, so negative 24. As a checking, since point B is a roller support, there should be a 0 moment at this point. So 24 plus negative 24 is 0. 0 moment for a roller. So this will be the equivalent moment diagram if you are using the area moment method. So how to determine the rotation at A, rotation at B? First, let us imagine the elastic curve or the deflected form of the beam. So let's say this is the exaggerated deflection of the beam. Or the term used is elastic curve. Alright, so initially, for example, we don't have a load. It is assumed that the beam is supposedly horizontal, and we are to draw a tangent line at point A, so intersecting the elastic curve at exactly 1 point. So this distance, the distance from the elastic curve towards the tangent line, this distance is the deviation from your initial point, point A, to the second point. This is point B. The deviation from A to B. So this will be the rotation at A. Let's say this is theta sub. Theta sub A. When the rotation at A, we have theta sub A, and on the other side, let's say this is the rotation of B, we have theta sub B. So to determine theta sub A and theta sub B, so let's first compute the deviation from A to B. So we have how to compute for the deviation from A to B, that is equal to the area of the moment diagram from A to B, multiplied by the distance of the centroid of that moment diagram towards your second point. Okay, so from this term, the deviation from A to B, can you observe the numerator? Or that is the upper letter, we have letter B, and the distance of the centroid towards point B. This is all over EI. So summation of the area of the moment diagram from A to B multiplied by the distance of their centroids towards point B. That is the deviation from A to B. So let's compute for that value. We have the deviation from A to B is now equal to, what is the area? First, the positive area. That is 1/2. What is our base? That is 3 meters. What is the height? We have 24 kilonewton meter. This is multiplied by, what is the distance of this centroid of a triangle towards point B? So for triangle, that is towards this direction, that is 1/3 of the length, 3 meters. Then plus, we have a negative area here, that is 1/2. Ano yung kanyang base? 1/2, the base is 2. The height is negative 24. Okay, what is the distance of its centroid towards point B? So this is only 2 meters. So yun yun. We have 1/3 of 2 meters. So this terms all over EI. So we'll be having the deviation from A to B is now equal to that will be equal to 20. This is equal to 20 over EI. So, if we have now this deviation from A to B, can you observe this triangle? This triangle composed by the tangent line, the length of the beam, and the deviation from A to B. So, if you are to observe this angle, if this is theta A, okay, this is the same as theta sub A. These are vertical angles. So, we can use the function of tangent. That is, the tangent of theta sub A is equal to, okay, this is tangent of theta sub A opposite. That is the deviation, okay, the deviation from A to B. Divided by, what is the adjacent side? Adjacent side is equal to, okay, we have 3 meters. Okay, for the function tangent, we have tangent theta is the same as theta if the value of theta is somehow a small value. Okay, so you may check that. For example, tangent of 1 degree, what is the equivalent of 1 degree in radian? That is approximately equal if we have a very small value of rotation. So we'll be having the tangent of theta sub A, or the same as theta sub A for a very small value of the angle, is equal to opposite. We have deviation from A to B, that is 20 over EI divided by the adjacent side, that is divided by 3. So we'll be having the rotation at A is equal to, we have 20 over 3 EI. And the unit of this one is, of the numerator is kilonewton meter squared. That is divided by 3 meters. What is the unit for deviation? As you can see, this is kilonewton meter times meter will be kilonewton meter squared times meter. This is kilonewton meter cube. Alright? So, kilonewton meter cube divided by 3 meters will be kilonewton meter squared. So that is the rotation at A. We have 20 over 3 EI. So how to compute for the rotation at B? For the rotation at B, we have to do the same procedure. Ulitin lang natin yung ginawa natin sa pag-compute sa rotation sa A. All we have to do is draw a tangent line at point B, passing through point B. Okay, so we call this distance from the elastic curve towards the tangent line. This is the deviation from, B to A. Okay, so how to compute for that value? We have the deviation from A to B, from B to A. So we have the deviation from B to A is equal to the area of the moment diagram from B to A. This is multiplied by the centroid, or the distance of the centroids of the areas towards, kung sino yung nasa numerator, nasa taas, towards point A. This is divided by EI. Okay, so let us compute for that value. We have the deviation from B to A is equal to, take note, ang distance yung consider natin this time is this one. So this is the same as, this is 2 over 3 of 3 meters. About for this one, the negative area. This distance is the same as 2/3 of 2 meters. This is 1 meter. So we have for the passive area, that is, we have 1/2, the base is 3 meters, the height is 24. The distance of its centroid towards point A is 2 over 3 of 3. Then plus, we have 1/2, the base is 2 meters, the height is negative 24. This is multiplied by the distance, we have 2 over 3 of 2 meters plus 1 meter. Alright? So 2/3 of 2 plus 1. So all over, this terms all over EI. I will be having the deviation from B to A, so equal to is equal to 16. 16 over EI. Okay, so again, we are going to use tangent. So triangulation lang naman to determine that rotation. So if the slope at this point is theta sub B, this angle is approximately or the same as theta sub B. So we may again use the function of tangent. So we have tangent of theta sub B for a very small value of the angle that is the same as theta sub B equal to opposite. That is the deviation from B to A, divided by the length of the beam. We have 3 meters. So we have the rotation at B is equal to what is the equivalent of deviation from B to A? That is equal to 16. This is 16 divided by EI divided by 3 meters. So we have the rotation at B is now equal to 16 divided by 3 EI. This is in terms of kilonewton meter squared. So again, if we have the deviation, this is the same as kilonewton meter cubed. So these are our solution for the computation of the rotation. So how about the deflection? So for the computation of the maximum deflection, first, we need to assume the location of the maximum deflection. So may mga cases naman na hindi natin alam yung location. You need to first allocate that point of maximum deflection. So let's assume that it will be here. Let's say at a distance x from A. So let's say this will be the y max, the maximum deflection of the beam. So let's say I'll be using again the tangent line from A. So if you are to draw a tangent line about point A, this is towards point B. This is the deviation from A to B. Which is equal to 20 over. I think that is 20 over EI. Deviation from A to B. So let's say this point will be point C. So we have this distance, the distance from the elastic curve towards the tangent line. Okay, this will be the deviation from your initial point from A to point C. Okay, the deviation from A to C. So we have what will be the magnitude of the moments on this point, at point C? So this will be, again we have an initial, or we have the reaction at point A as 8 kilonewtons. So the moment about point C will be 8 times x. So the magnitude of the moment here will be 8x. Okay, so if we have this as 1 meter, ano naman yung distance dito? If this is 1 meter, this will be, this distance will be, we have 1 meter, this distance is x. Okay, we have x minus 1. What is the magnitude of the moment here? That will be 12 times x minus 1. So we'll be having negative 12 times x minus 1. That will be the magnitude of the moment. So we have, on the positive area moment, we have 8x negative. This is 12 times x minus 1. And how do we compute for the maximum for the location of the maximum deflection? So first, if we are to draw a tangent line about that maximum point, kung gagawa tayo ng tangent line dito, again, this tangent line should be horizontal, and this is the rotation at A. So what will be the angle or the value of this angle? Okay? The angle formed by the tangent line drawn at point A and the tangent line drawn at point C. So ano yung magiging angle na to? So as you can see, if this is horizontal, the same with the longitudinal axis of the beam, pareho silang horizontal. For example, this is the beam, which is at point A, gagawa tayo dito ng tangent line. Okay, so again, we have the beam is horizontal. We draw a tangent line at point A. This is the theta of A. So we draw another horizontal tangent line at point C, that is on the maximum deflection. So what will be this angle? So again, we have two parallel lines cut by a transversal line. So if that happens, if this is theta A, this is the same as theta of A. Okay, this is the same as theta of A. So here in area moment method, what is the equivalent of theta, or the slope, or the change in slope? So slope is basically equal to the area of the moment diagram. So we'll be having this theta of A is the same as the area of the moment diagram from A to C. So let us compute for that value. So a while ago, or yun kanina, we are able to compute for the rotation at A. The rotation at A is equal to 20 over 3 EI. This is in terms of kilonewton meter squared. So let us compute for the rotation at A. We have the rotation at A is equal to the area of the moment diagram from A to point C. Yun yung assumed location natin ng maximum deflection. So what is the positive area? That is 1/2. Or dito na muna. What is equivalent of theta sub A? This is 20 divided by 3 EI. Equal to area of the moment diagram from A to C. Okay, positive. What is this distance? That is, we have 1/2. The base is x. Ano yung kanyang height? We have 8x. Okay, plus, how about the negative area? The negative area, we have 1/2. What is the base? What is this distance? That is the same as x minus 1. Ano naman yung kanyang height? Okay, what is the magnitude of that moment? Caused by this 12 kilonewton. At that point, we have negative 12. This is negative 12 divided by x minus 1. Okay, so we'll be having, let us simplify. This is 20 divided by 3 EI is equal to 1/2 of x, 8x is 4x squared. Then, okay, we have 1/2 of 12 is negative 6 multiplied by x minus 1, x minus 1. This is x minus 1 squared. Okay, sorry. So this is supposedly over EI. Hindi ko naman nailagay yan. So this is all over EI. Okay, equivalent of rotation is the area of moment diagram from A to C divided by EI. So by the way, makakancel naman ito. So divided by EI. So we can eliminate EI. So this is 20 over 3 is then equal to 4x squared minus 6 times x minus 1 squared. Let us compute for the value of x. So the value of x na equal to 1.367 meters. That is the location of the maximum deflection from A. So let's compute for the equivalent of the maximum deflection. Okay, so we have the value of x equal to 1.367. So let us determine the equivalence of these moments. We have, this is the moment about, hindi naman siya yung actual moment. Yung may equivalent lang ng mga values na to sa moment diagram natin. Is equivalent of 8x, that is equal to 8 times 1.367 is equal to we have 10.936. This is kilonewton meter. About dito sa ilalim, and then negative 12 times x minus 1. So we have negative 12. This is 1.367 minus 1. And we have this is equal to 4.404 kilonewton meter. Alright, so let's replace with these values. So 8 times x is this is now equal to 10.936. Ito naman, supposed to be negative. Since nasa negative area moment siya, this is negative 4.404. Okay? So, before we compute for the maximum deflection, we need also the value of the deviation from A to C. Okay, so this is the deviation from A to C is equal to the area of the moment diagram, that is between A and C, multiplied by the distance of the centroid of the moment diagram towards point C. This is divided by EI. Okay, so again, so distance of the centroid towards C. Okay, so we have, this is now the deviation from A to C is na equal to, okay, positive area. Ito yun. We have 1/2. What is our base? Yun yung x. 1.367. What is the height? That is 10.936. Okay, then the distance of its centroid towards point C is obviously 1/3 of 1.367. Okay, this is divided by EI. Okay, plus the negative area. Ito yan. So, by the way, this distance is 1.367 minus 1 is 0.367 meter. So that is 1/2. Ano yung base? 0.367. What is the height? We have negative 4.404. Distance of its centroid towards point C, that is 1/3 of 0.367. I over EI. So this will be the value of the deviation from A to C. As we have the value, deviation from A to C is equal to 3.307. I just divided by EI, kilonewton meter cube. So why did I compute for the deviation from A to C? So can you observe these triangles? So let's say this is point B. We have here the deviation from A to B. We have this distance. Let's say this is Y max. Ito naman yung deviation from A to C. So ito yung distance x equal to 1.367 meters. And the length of the beam, we have 3 meters. Ayan. So ratio and proportion of similar triangles. That is, we have the deviation from A to B is 2. Okay, this distance is to 3 meters equal to, how about this distance? That is the same as the maximum deflection plus the deviation from A to C. This is divided by the value of x, which is 1.367. Then we substitute. What is the deviation from A to B? That is 20 divided by EI. Is to 3 meters is equal to Y max, unknown. Okay, plus the deviation from A to C, ito yun, is equal to 3.307 divided by EI. And this is all over. We have the value of x. So the value of x, we have 1.367. So we have the maximum deflection is equal to, that will be in terms of EI. So this is the same as 20 divided by 3 times 1.367 minus 3.307. So we have 5. This is 5.0806 over EI by kilonewton meter cube. Okay, so this will be the maximum deflection of the beam. Okay, so this is our example for the area moment method. First example. Okay, so our next example, for example, we have this cantilever beam. It is loaded with 15 kilonewtons per meter over a span of 6 meters. So let's assume again that EI to be constant. So record the rotation at A, that is on the free end, and the maximum deflection. So let's first construct the equivalent area moment. Okay, so when we observe this one, if we have this type of load, so it is a varying load, this means this is a first degree. So if we have a first degree loading, supposedly the shear diagram will be second degree and the moment diagram will be third degree. So again, we choose a fixed point to do the moment. So let's say the moment, I'll be choosing point B again. So we are to do a moment about this point. So that's only the moment caused by the load 15 kilonewtons per meter. So that we can eliminate this moment, the moment about B. So we have this, the magnitude of that moment is basically equal to 15 times 6 over 2. That is the magnitude. Then the lever arm is 1/3 of 6. But as you can see, this will be towards the negative, towards the negative area. So this is equal to that will be equal to 90. So this is the 90 kilonewton meter. Supposedly that is the moment reaction at point B. But if you are to observe the direction of this loading, that is towards the negative area. So if this is first degree, supposedly shear diagram second degree, and the moment will be third degree. So this is a third degree curve. With a magnitude of negative 90. So a negative 90 moment plus supposedly the reaction of 90 kilonewton meter. That is the moment about the fixed support point P. So we have now that moment. So let us imagine the equivalent elastic curve of this beam. Supposedly this is the deflected form of the beam. So we are to determine the rotation at A and the maximum deflection. Obviously, our maximum deflection will be at B. So we are to draw a tangent line at point B. Alright, so let's draw a tangent line about point B. And since that is a fixed support, the tangent line for a fixed support is assumed to be horizontal. Okay, and this is the point A. So if I were to draw a tangent line, okay, on the deflected form of the beam at point A, okay, so this will be the rotation about point A. So let's say this is theta sub A. So how to compute for the rotation or the slope at a given point using the area moment method. That is basically equal to the area of the moment diagram. So since I draw a tangent line from point B to point A, that is the area between A and B. That will be the rotation of A. So bakit the area of the moment diagram from A to B? For a reason, our reference line is a tangent line from passing through point B, which is a horizontal. So, di ba, if we are to compute for the rotation, our basis is a horizontal line. And that is a horizontal tangent line passing through point B. So, from point B to point A, what is the area of the moment diagram? So, let us compute. Okay, for a spandrel, how to compute for the area of a spandrel? Okay, the area of a spandrel is equal to, this is 1 over n plus, kapag area n plus 1, base times the height. So n is the degree of the degree of the curve. So let us compute. This is the rotation at A. Supposedly this is divided by EI. Kalimutan ko lang naman. The rotation at A will be equal to, so what is the area of the moment diagram from point B to point A? That is 1 over what is the area? What is the degree of the curve? We have the degree of the curve is equal to third degree. This is equal to 3 plus 1. What is the base? So pwede tayo mamili. It's either the base is 90, then this is 6 meters. So we'll be having this is equal to negative 90 multiplied by 6 meters. So this is all over EI. So we'll be having the rotation about A. Mapapansin nyo, we'll be having a negative value. So this is equal to negative 135. So the unit of this one will be in terms of kilonewton. If you are to observe, this 90 is kilonewton a meter. Okay. So multiplied by 6 meters, this is kilonewton a meter squared divided by EI. So this will be the rotation about A. So why do we have a negative slope? So again, if we have the value of theta is negative or the slope is negative, which means the curve opens downward. If we have a positive theta, it only means that the curve opens upward, or the bend of the beam is it opens upward. So we have the negative value, it only means that the beam is opens downward. Alright? So let us determine the maximum deflection. So for the maximum deflection, okay, so this is a tangent line drawn from point B, yung kanina. So tanggalin ko lang. Okay, so this is the value of the maximum deflection. Let's say this is Y max. But as you can see, it is also the distance. It is also the distance of this tangent line towards the elastic curve. So what is the equivalent of Y max from that figure? So we have Y maximum is the same as the distance from the tangent line towards the elastic curve. So this is the same as the deviation from B to A. Yun yung equivalent ng maximum deflection for this example. How to compute for that deviation? that is equal to the area of the moment diagram from B to A, ay multiplied by the distance of the centroid. The distance of the centroid of this moment diagram towards point A. So ito yung gagamitin natin. Supposedly, we have x of A. So this is x of A all over EI. Okay, so let's compute. This is now y max is simply equal to the deviation from B to A. What is the area of the moment diagram? This is negative. Okay, by the way, I have to compute for that distance. How to compute for this distance? Okay, so towards this side, towards the 90. Okay, let's say sabihin ko na lang bar x muna. Okay, we have the value of the bar x is equal to 1 over n plus 2 of the base. So, kapag area, if you have the area, is 1 over n plus 1 base times height. If you are locating the centroid of a given spandrel, that is 1 over n plus 2, then this distance, which is the 6 meters. So, ito yung gagamitin natin na base, the 6 meters. So, we have bar x is equal to, this is 1 over, what is the degree of the curve? We have 3 plus 2 multiplied by 6. So this is the same as 6 over 5. What is 6 over 5? That is 1.2 meters. So if you are to compute for the value of x of A, we have x of A is equal to 6 meters. Okay. 6 meters minus bar x, or this is minus 1.2. We have x of A is equal to 4.8 meters. Okay, that's the distance of the centroid of this spandrel towards point A. So computing for the maximum deflection. So again, we have y max is basically equal to the deviation from B to A. And this is equal to the area of the moment diagram from point B to point A divided by x of A all over EI. So we have, this is now y max is equal to, what is the area? The area is 1 over, what is the degree of the curve? That is 3. We have 3 plus 1 multiplied by the base. We have 6 times negative 90. Okay, then it's x of A. Ano yung nakamit natin na x of A? We have, this is 4.8. Okay, this is all over EI. So we have the maximum deflection of the beam. So obvious naman kapag cantilever, the maximum deflection is on the free end. So let's compute for that value. Is equal to negative. We have negative 648 divided by EI. So what is the unit of the numerator? If you are to observe, this is kilonewton meter times meter. That is kilonewton meter squared times 4.8 meters is the same as the kilonewton meter cube. That will be the unit of the numerator. And this will be the maximum deflection. Okay, so those are our answers using area moment method.